We'll work this final example here. This should be a fairly short video. R equals 4 sine of 3 theta, the same function we were working on in the last video. But this says find the tangent lines at the pole. For us, tangent lines for polar functions are theta equals. Anytime that we are in the plane and we have a function in the plane, we said this one looks something like this, and we want the tangent lines at the pole. So we want the lines that are tangent to this function, like here and here, that go through the pole. We give those as theta measures. Theta equals whatever the theta measure is for that angle from the standard position. All right? So these tangent lines are going to look like theta equals some real number value. Okay, so we want the tangent lines at the pole. At the pole, r equals 0. All right? So we want this function, 4 times the sine of 3 theta. We want to know the values where that equals 0. So we can divide both sides by 4, and that gives us the sine of 3 theta equals 0. Taking the sine inverse of both sides like we did before is going to leave us 3 theta on the left side, and then of course the sine inverse of 0 says for what angle measures, for what theta, does the sine of theta equal 0? Well, we said before we know that that happens at 0, it happens at pi, it happens at 2 pi, and we could keep going. It's going to happen at 3 pi, it's going to happen at 4 pi, and so on. We just keep going and going and going. So we can set 3 theta equal to all of these values, and we can find the theta measures that make that a true statement within 1 revolution of our theta measures. And then we could keep going. 3 theta equals 4 pi, and we, etc., or so on, or however you want to put it. So here we have theta measures of 0. Here the theta measure is pi over 3. Here the theta measure is 2 pi over 3. Here the theta measure is pi, and you can see we're still within 1 revolution here. Here the theta measure is 4 pi over 3, so we're still in 1 theta measure, and we could keep going. 5 pi over 3, and then 6 pi over 3, or 2 pi. And then we could say, plus k, 2 pi k. It's just going to keep going all the way around again and again and again. But then again, we're just going to wind up with the same lines in the plane. That kind of goes back to our work in trigonometry, what we see there. So in the xy coordinate plane, even though we give dy dx in terms of theta, here the tangent lines are going to be the angle measures within 1 revolution that the tangent lines are going to follow whatever direction they've given you. Here they want them at the pole. They could have said where r equals 10 or where r equals 3 or whatever, but at the pole we know r equals 0. So they can ask you some fairly different things to do here with polar curves that are not exactly like what we've seen working with Cartesian curves in the plane. So that's going to finish up this lesson. This is a short video. Come to class next time and we'll work some examples on slope of the tangent line given polar functions.